Welcome back, Prep Station Physics UTME 2025. Okay, yes, let's solve some questions before we move to another topic. Okay, here we have what is the acceleration between 2 points on a velocity time graph which has coordinates 10 seconds, 50 meters per second, and then 35 meters per second. All right, so I will not waste time in solving that. So just find the difference between the velocity. How do you do that? Here you have the first coordinate, call this 1, call this 2. So this is initial and then this is final. Okay, let me just do it. So you have acceleration. Come on, acceleration A is equal to change in velocity over change in time. So what is the velocity here? We have the first coordinate 10, 15. We have the second coordinate 20, 35. So this means V2 minus V1 over T2 minus T1. So A will be equal to, what is V2 now? V2 is 35. Then minus V1 is 15 over. Then T2 is 20 minus T1 is 10. So A will be equals to 25 minus 15 is what? 25 minus 15 is 20 divided by 20 minus 10 is what? Is 10. So 20 divided by 10, that will give you 2 meters per second squared. Hope that was simple enough. So let's move forward. Question number 3, and this was extracted from the year 2008. If a wheel 1.2 meter in diameter rotates at 1 revolution per second, calculate the velocity of the wheel. If a wheel 1.2 meter in diameter rotates at 1 revolution per second, calculate the velocity of the wheel. Now, there is a formula that relates linear velocity and angular velocity, and that formula is linear velocity equals to R omega. Now, omega is called angular velocity, R is the radius of rotation, and then V is the linear velocity. Of course, according to circle geometry, diameter or radius, diameter is equal to radius times 2. So to get the radius, all I need to do is to divide the diameter of the wheel by what? By 2. So the radius is 1.2 divided by 2. Now here we have revolution per second. Revolution per second, that is the rotation of the wheel per second. So you have your omega revolution per second. Where is it? 1 revolution per second. So by the time you apply that and put it into this formula, you get the answer for this question as 3.77 meters per second. So let's move forward. Now, an object of mass 80 kilogram is pulled on a horizontal rough ground by a force of 500 Newton. Find the coefficient of static friction. Find the coefficient of static friction. Okay, so as usual, let's get our parameters from the question. What do we have? We have mass as 80 kilogram. And what else? We have force. F, force as 500 Newton. And what else? We are looking for coefficient of static friction, mu subscript s, question mark. Now the formula that relates mu and friction is frictional force F, static friction now, is equal to mu F subscript n. Now what is mu? Is the coefficient of friction we're about to find. And then Fn is called normal force. Now what is normal force? Let me explain that. Now normal force is the reaction force when an object sits on another object. For example, if you have this as an object sitting on a table, okay, now the weight of this object is acting vertically downward, Fg, force of gravity, and then the table is reacting with a force known as normal force, F subscript n. So in a situation where the table is not making a vertical motion, as in this question, then normal force will be equal to Fg. So the question now is, what is Fg? Now, Fg is called gravitational pull, and it's the product of mass times acceleration due to gravity. So that means the Fn I'm talking about is equal to Fg, and Fg is equal to mass. The mass was 80 times g, acceleration due to gravity, given as 10. So put 10 here. So that means Fn will be equal to what? 80 times 10, 800 Newton. Now that I have Fn, let's go for what now? Let's go for, by a force of 500 Newton, okay? Find the coefficient of static friction by a force of 500 Newton. So let's make mu the subject of the formula. So if you make mu the subject of the formula from this, then you are going to get Fs over Fn. So Fs is what? 500. 500. Or, okay. Then over Fn is 800. Of course, by the time you work on this, this cancel this, you are left with 5 over 8. So 5 divided by 8, I'm not with calculator. So if you do that, that will give you the answer to this question as 0.6. Of course, if you do that in decimal, 5 over 8, let me quickly confirm that. So 5 over 8, so if you convert this 5 in 50, that is 6, 0.6 times this, 48. Of course, that will give you the 0.6 that is displayed here. So let's move forward. I believe that was clear enough. Okay, particles of mass 10 raised power 2 kilogram, this 10 raised power 2 kilogram is fixed to the tip of a fan blade which rotates with an angular velocity of 100 per radians. If the radius of the blade is 0.2, the centripetal force is what? Okay, so let's solve this quickly. How do we calculate this? Now, centripetal force by formula is mv squared over r. And then v is related to angular velocity by this formula r omega. But what we have from this question, we have the mass as m equals to 10 raised to power 2 kilogram. What else? Angular velocity omega, we have it as 100 per radians, so 100. What else? If the radius of the blade, so we have r as 0.2 meter. So how do we find the centripetal force? So all I need to do is to involve this in this formula. So let's rewrite this formula since we don't have v, but we have angular velocity. So F will be equals to m into, in the place of v, I'm going to write r omega in bracket squared over r. Now, if you continue with this, you have m r squared omega squared over r. Of course, one r will disappear from there. So we are left with F equals to mr omega squared without the r. So all I need to do, substitute these values into this formula to get your answer. So F will be equal to, what is the mass? 10 raised to power minus 2 kilogram times, what is R? 0.2. And then what is omega? 100. So that will be 100 squared. So if you play with all of this, of course, this is 10 raised to power 2. Okay, this is 10 raised to power 2. And then to go with this, cancel out, then I'm left with 0.2. So if you play with all of this, you will get the answer for the centripetal force. Let me be sure. The blade is 0.2. Yes, 100 rad and what else? 10 raised to power minus 2 kilogram. Okay, all right. So if you do all of that, you get your answer as 20 Newton. Now let's quickly move. Question number 6. A body of mass 4 kilogram resting on a smooth horizontal plane is simultaneously acted upon by 2 perpendicular forces of this and this. Calculate the acceleration of the motion. Now this is coming up again, perpendicular forces. So what do? Apply component vector. So this is vector 1. The value is what? Vector 1 is 6 Newton. And then vector 2 is 8 Newton. So the resultant vector will be a line drawn from this point to this point. So what do? Find the resultant force. Since this is a right angle triangle, simply apply what? Pythagoras theorem. Let's call the resultant R. So R squared will be equal to 8 squared plus 6 squared. This is 64 and this is 36. So R will give us what? This is 100. Okay. So R is equal to 10 Newton. Now applying Newton's second law, F equals to ma. So A will be equal to F over M. F is what? 10 Newton. M is 4 Newton. So when you play with this, A should give you 2.5 meters per second squared. Okay? Yep, that's correct. Let's quickly move to another question. All right, so a car accelerates uniformly from rest at 4 meters per second squared. How far will it travel in the fifth complete second? Fifth complete second. Very simple question as well. You just need to understand the logic, how these questions are being presented. Now, a car accelerates. So this number you are looking at represents acceleration. So 4 meters per second squared. How far will it travel? So we are looking for what? Distance, question mark. In the fifth complete second, all right, fifth complete second. So let's look at time of 5 seconds. Let's see what that will be. But something is still missing. What is missing? Initial velocity. A car accelerates uniformly from rest. Rest means 0 velocity. So you have u is equal to 0. So quickly scan through the 4 equations of motion to find out